Alright, so if I gave you a function that said g of x equals x plus 4 squared. G of x equals x plus 4 squared. The directions say to describe the transformation of f of x equals x squared. So we remember the parent function of a quadratic is x squared, f of x equals x squared. So we want to describe how that one is different. So what do you think? I've heard 4 units. What did you say over there on that side? I hope you said it a little bit different than she said it.
I said that the x is plus 4, so it would be the opposite, the left 4.
Okay, it's got to go to the left. Remember, we just talked about that horizontal stuff is always the opposite. So in the parentheses with the x means it's going horizontal, right or left, and it's the opposite way with the x. So since that says plus 4, it'll actually go left 4 units. Now, what else? Is there anything stuck out on the end to move it up or down? No. Is there anything out in front of it to make it stretch or shrink? No. So that's it. That one would just go left 4 units. That's all you'd have to put on something like that. Okay? Alright, what if I had g of x equals x minus 7 squared plus 2? And the directions are the same. Describe the transformation. Okay, in with the x, I see a minus 7, and when I'm in with the x, it's always the opposite way. So the opposite of minus 7 will be right 7. Everybody okay on that? Then I got something stuck out on the end. What does it do when it's stuck out on the end?
It goes up or down.
Up or down, but it's the right sign. So if it says plus 2, that means a positive 2, which would mean up 2. Everybody remembering those? Pretty easy on that so far? Okay, let's look at one more. This one says g of x equals negative 3 times x plus 2 squared minus 1. This one's got 1, 2, 3, 4 things happening on it. 4 things happening there. Tell me what one thing is, Kylie.
It goes left 2 units.
Okay, it's got to go left 2 units. She got that from that right there. Everybody agree on that? Mm-hmm. Left 2 units. That's one of the 4. Okay, Mason, tell me something else it does.
Goes down 1.
Goes down 1. Got that from that minus 1 stuck on the end. Very good. Now, bad news for the rest of y'all. Kylie and Mason just got the obvious 2. So, okay, Macy says since it's got a negative in front, it's going to be reflected on the x-axis, and that's right. That's 3. We got one more thing that we haven't talked about yet. That's to do with that 3. Okay, if it's out in front of the whole thing, that means it's vertical. Now, if it's 3, I describe 3 as being a number that's bigger than 1, right? So if I'm bigger than 1, it's going to be a stretch, and that is what Macy said. If it had been a fraction or a decimal, it would have been a shrink. Remember all that stuff? That's been a while since we talked about all that. Very good. Thursday.
Wait, so my birthday, the test,
What I do?
so the negative means a reflection.
Uh-huh. Alright, now let's go do one or two the other way. I'm going to tell you what it did, and we got to write the equation. Okay, so this says g, we're going to write a g function that has a horizontal shrink by a factor of 2/3, a translation of 5 units left and 2 units down. That's it. Started off at your parent function of f of x equals x squared. We got to take that x squared and do all this stuff to it. Okay, so the first thing, a horizontal shrink. If it's horizontal, it goes in with the x. Everybody remember that? 2/3 x squared, right? Okay. Now that takes care of that part. Now next I got 5 left. What does 5 left look like? Gonna add 5. Now what I'm gonna have to do here, where's the parentheses gonna go? I mean, I am gonna close it there, okay, because I gotta square that. Am I gonna go in between here?
No.
Okay, because that 2/3 has got to be in there with it.
Squared off of those.
Yeah, so that I don't need a double square. Thank you. That would make it a 4th. That'd be no bueno. Wouldn't be a quadratic anymore. And then -2 on the end.
So that would have been like right as 1/4 dollars. The
Yeah, just-
parentheses would have gone after 2/3.
Uh-huh. All right. Then after we did that, after we did translations and all that for a while, we got into talking about vertexes and axes of symmetry and all that. So here I've got f of x equals 3 times x minus 1 squared minus 4. Alright, we got several directions on this. Graph, label the vertex, axis of symmetry, min or max, and what is it? And we're also going to tell where it is increasing and decreasing. We had that on a worksheet and haven't talked a whole lot about it, so we'll discuss all that stuff now. And we also, I'm not going to have you now, but remember when we did this earlier in the unit, we also talked about domain and range, but we'll leave that off for right now. Alright, before I graph it, I already know what most of this stuff over here is. I know the vertex. What's the vertex? 1, -1. Everybody okay on that? That's just like the bell ringer. Now my axis of symmetry is which part of the vertex? So my axis of symmetry is x equals 1. My max or min is which part of the vertex? The y. So my max or min is going to be y equals -1.
Would it be max?
But is it going to be a max? -1. Is it going to be a max or a min?
Max, because it's based on your A, right?
Yes, it is based on my A, but no, it's not a max. If my A is a positive number, that means the parabola will look like that, right? Which means that vertex is the min. So it's a minimum at y equals -1. Alright, so let's go ahead and draw our graph so we can be more specific with the increasing, decreasing. Let me get an xy axis. Put all that pretty stuff on there. It's got a vertex at 1, -1, which means that is its axis of symmetry. Y'all need to remember doing all this. Which now, all we did after that to get our other 2 points is we picked an x that was not touching the axis of symmetry. So I could pick like a 2, a 3, or a 4 or something and plug that in. Or I could pick a 0, a -1, a -2, something and plug that in. My preference, and I talked to y'all about this, is if I can do 0, I do. The zeros are easy to work in my head. So if I plug a 0 in on that, put a 0 in the x spot, 0 minus 1, and you got to do it in the parentheses first. Some people messed this up when we looked at it earlier. 0 minus 1 is -1, and then the squared comes next. -1 squared is 1. So that's just 3 times 1, which is 3, minus 1, so that would be 0, 2. So I go over 0 and up 2. It'd be right there. Now, this is where we get to just count, common sense math. If that's the axis of symmetry and I'm 1 away from it on that side, I got to be 1 away from it on the other side, don't I? So there's your pretty parabola. Okay, so we've got everything. We've got a graph, we've got a vertex, we've got an axis of symmetry, we've got a min, increasing and decreasing. If I start reading this on the far left arrow, I see that it's going to go downhill first, right? it's going to go downhill, that's decreasing, until it gets to that vertex, right? So it is decreasing everywhere, and you could say this lots of ways. I'm going to try to keep this simple. It's decreasing everywhere that is smaller than x equals 1. So I'm going to say decreases everything to the left of x equals 1. Lots of other ways I could say it decreases from negative infinity to 1, right? Because from to the left is negative infinity, but we'll just say it decreases from the left to x equals 1. Now, once it hit x equals 1, it made a sharp turn and started going uphill. Uphill is increasing. So it increases to the right of x equals 1. Right?
So it's basically decreasing until you get to a vertex, and then if it's a max, then it'll be opposite. There was like one.
Yeah, we're going to do 2 more of those. Alright, everybody got what you need off that one? Same directions on this one. We're going to graph. Find the vertex, axis of symmetry, min or max, and where does it increase and decrease. And our function this time is g of x equals negative 2x squared plus 16x plus 3. Alright, first off, before we jump into it, I want you to compare this one to the last one that we just did. What form was the last one that we just did written in? It was written in Vertex. The last one that we just did on the previous page was written in Vertex. So it automatically told you the Vertex. This one, it's written in what? Standard form. So it doesn't tell me the Vertex. So I got a little bit more work to do before I can just start answering my stuff over there. When I'm in standard form, I start by finding my axis of symmetry by doing negative b over 2a. Everybody remember that? So in this equation, I've got an a of negative 2, a b of 16, and a c of 3. I don't really need my c now, but I always write it when I write everything else. So my x is going to be equal to negative 16 over 2 times negative 2. 2 times negative 2 is negative 4. Negative by negative is a positive, so that would be 16 divided by 4. So, everybody okay on that? Axis of symmetry over here is x equals 4. So my vertex is going to be 4 comma something. How do I get the comma something?
Plug that x in.
Take the 4, plug it in up there and solve. So it's going to be negative 2 times 4 squared plus 16 times 4 plus 3. Okay, do your power first. 4 squared is 16. 16 times negative 2 is negative 32. 16 times 4 is 64. Negative 32 plus 64 is 32. So that gets me a y of 35. That's not friendly for graphing.
You just do like a break in the graph.
I probably will just not count at all. Just go up a ways and say that's 35.
Back to that.
Alright, now that also, we got a vertex, we've got an axis of symmetry, so I have a min or a max now. It's my y. So it's at y equals 35, but is it a min or a max?
It's a max.
Okay, since my a is negative 2, that means it's going to be opening down, so that is a max.
So if your a is positive, it's a min.
Yes.
So it's the opposite of what you would think.
Yes.
Like positive.
Yes.
I wrote that down.
Okay, so increasing and decreasing now. This thing goes up first, so it's going to be increasing everything to, that's my axis of symmetry, which is at 4, right? It's It's going to be increasing from everything that is left of x equals 4. And then it goes downhill after 4, so it'll be decreasing everything from the right of x equals 4. Okay, so when you get that caught up, we've got everything drawn except for the graph. Everything we need except for the graph. I'm going to erase some of my work there and let you draw my graph.
Did you ever go to the game
Yes, sir. No.
You did this, right?
Alright, to put my vertex on there, first thing I did was I made it bottom heavy. And this is what I was telling, I will cheat on this as much as I can, because I'm not going to want to count all the way up to 35. So I'm going to say over 4 and up to 35. That looks like a good spot to me. That was technical, wasn't it? Alright, that's where my axis of symmetry is. Since I'm cheating here, I better label some stuff, so let me label that. That's x equals 4. Alright, now we know we've already said it's going to open down. So I think 0 again would be a good one to plug in. And that's pretty friendly on this one, because if I plug a 0 in there, that whole piece is gone. 0 there, 16 times 0, that's gone. All I'm left with is 3.
I just did like x equal, like I did 3 and 5 because they're on each side.
Good.
Like
Yeah. So I'm going to go over 0 and up 3. So I'll be right about there. Can't make that be very high since that's all the way to 35, right? Now what Kylie said, if this is 4, to get there, I would count over 4. Well, that's not what Kylie said. I would count over 4, so then I got to go over 4 more, which that would make that be an 8, 3. I know you're still right, Kylie. I know what you meant.
Yeah. I feel like I'll mess up on county or something.
Yeah. What Kylie's talking about, since our vertex was at 4, she stayed real close to that. She plugged a 3 in and then saw how high that would be, and the 5 would be its mirror image. So she had, where I've got 0 and 8, she would have 3 and 5. So still works the same deal on that. Alright, we'll look at one more of that type. We did the first one in vertex form. That one was in standard form. We know another form, so that's what the third one that we're going to look at will be in. Alright, it says h of x equals x minus 3 times x plus 7. We want all the same stuff. The graph, vertex, axis of symmetry, min max, increase decrease. Alright, do you remember what we did to find vertex when we were... Okay, we just had, because these are going to be where it crosses the x-axis. Those are your x-intercepts. So the vertex had to be halfway between those. So this is, remember, this is x minus p, which means that p would be 3. This q would be negative 7. Remember, it's the opposite signs on those. So I'm going to do 3 plus negative 7, and half that, that's going to tell me my axis of symmetry. 3 plus negative 7 is negative 4. Half of that is -2. So there's your axis of symmetry.
Wait, why would you switch these out? Yeah, because it wouldn't be the same answer if you didn't. It would be positive.
It would be on that, but your graph would not be right. And it would be a +2, you're right, because -3 + 7 is +4. Now the P and Q, remember the formula, the intercept formula said x minus P, x minus Q, where P0, opposite sign, and Q0, opposite sign, are your intercepts. So we made the opposite signs down there. Alright, now to get the vertex, I'm going to take that -2 and I'm going to plug it back in and solve for y, because I know my vertex is going to be -2 something. So I would add -2 minus 3 times -2 plus 7. -2 minus 3 is -5. -2 plus 7 is 5. So it's going to be -25. Be the other part of my vertex. So that is also my min or my max. Y equals -25. Can't get my negatives in there today. Messing that up. My A is 1. There's no number in front of that. It's a +1, which means it's going to open up. So that would be a min. Okay, so if we're a min, we start reading left to right. It's going to go downhill first, isn't it? So it's going to decrease to the left of x equals -2. And then it goes uphill, so it will increase to the right of x equals -2.
So if it's a min, it decreases first, and x it increases first.
Alright, last thing I'm missing, it looks like, on my graph is my graph. So let me erase some of this mumbo jumbo and get my graph. Intercept form, after you found all that, in my opinion, is easiest to graph because you don't have to find anything else. You don't have a third point to find. You already got it. So we said it's going to have a 3, 0. And a -7, 0. So there's where it's going to cross. Its vertex is going to be at -2, -25. So that is enough. That's 3 points. You've got enough to draw your parabola. Hopefully yours is prettier than mine. After we did vertex and axis of symmetry, the next thing we talked about was focus and directrix. Didn't spend as much effort on that because it's not something that is common. Still not going to spend a whole lot of time, but I do want you to know how to write equations when you're given it. Remember, focus and directrix was the weird stuff because it always started with the 1/4. Remember that? If I had, if I was horizontal, I started like that. If I was vertical, remember that? Now remember this stuff? So there'll be an X there. Alright, so if I gave you stuff about a parabola and said it's got a vertex of 0, 0, and it's got a directrix at x equals 2. Asked you to write the equation of the parabola. Alright, first off, since my directrix says x equals, I know it's going to start off in this parabola. The only tricky thing on this, your directrix, and if they give you a focus in a minute, your directrix and your focus are directly related to your P. You just got to remember when it's the opposite sign and when it's not. So if I've got a directrix of x equals 2, what is my p? Negative 2. Okay? So all I got to do is plug that in. That's going to be x equals 1 over 4 times negative 2 y squared, which is 1 over negative 8 y squared. If you leave it like that, I'm not going to mark it wrong. But most of the time, this positive divided by a negative makes a negative. So most of the time, you'll just put the negative in front. But it doesn't matter. It can technically go anywhere as long as it's only in there once. Because a negative divided by a positive makes a negative. That'd be it. That's your equation. Mm-hmm.
Is this what we were doing before?
Mm-hmm. We did this. Yeah. What was your question? Yes.
Then I'll probably
Good. Good to good. Alright. This next one is going to make it be a little bit harder. We've got a focus at 2, 2 and a vertex at 2, 6. Alright, standard parent function is that, right? X squared. But I've moved that. This x squared would have a vertex at 0, 0. We're not starting with the vertex at 0, 0. So we're starting at, let's see, does this one have a letter? No. We're starting at g of x equals, my vertex is at positive 2. Wouldn't that be how that one would start? Okay, so all we've got to do to that now is figure out what is this? I can't think. A. What goes in front of it? What your A is going to be on that. That's what we're dealing with on this.
So could you just plug in your x and y and vertex? That 2 and x and y?
Should work. I don't know if that's what I want to do though. What makes you saying should work? But since I'm dealing with focus and directrix, I'm going to stick to my 1/4 thing that we got on this. So I'm going to say y equals where did I get that? Hold on. H equals 2, K equals 3. I don't understand what I did. Yeah, I do. Alright. If we had a vertex of 2, 6, 4, 5, 6. If we had a vertex there, the focus on this would be 2, 2, which would have to be right there, and focus has to be inside the parabola. So that means that my parabola would be looking like that. The focus would have to be there. Now what we know about the focus and the vertex and the directrix and everything is that the vertex is halfway between them. So if this vertex is at 6 and this is at 2, what would the directrix have to be at? If I go from 2 to 6, how far do I go? So then I got to go up 4 more. So my directrix would have to be at, what would be up 4 more to be up there? 10. So I'm looking at a directrix of y equals 10. Okay, there's your directrix on that. Okay, so to write all this now, we got y equals 1/4 times, what's my p?
-2.
It comes from my directrix. My directrix is 10. And then we already know everything else. Now that one was a little bit harder because it was scooted, but you still did this stuff, this part of it the same. And then just look at it as two separate problems. You know how to, we spent the beginning of the class reviewing over these scoops. You know how to do that. So it's just putting it all together kind of. Let's look at this now. This is what we did most recently. This is the more common stuff. I'm a parabola and I go through the point 112 and I have a vertex at 10, -4. Directions say write an equation for me. I go through the point 112, I have a vertex at 10, -4. So if I have a vertex, am I going to start off with which form? Vertex form, which is y equals a times x minus h squared plus k. The point I go through, that's your x and your y. The vertex is your h and your k. So this is what we did most recently. We're going to use all this stuff to solve for a, and then just rewrite our equation. This is what y'all liked when y'all were good at this. So y equals 12 equals a times x, which is 1, minus h, which is 10, squared plus k, so plus -4, or you could just write -4, means the same thing. 1 minus 10 is -9. -9 squared is 81. What do I do to solve for a? Add 4. Y'all remember this? Y'all were good at this last week. 12 and 4 is 16 equals 81a. Then what? Divide by 81. Don't think that will reduce, so I'm just going to leave it as 16 over 81. If you want to put it as a decimal, you can. I'm going to leave it as a fraction. So I'm going to take that a, I'm going to plug it back in with my h and k. Remember, leave your y and x, your letters. So y equals a times x minus 10 squared minus 4. That's it.
And what we did just before this, we just looked at the Directrix.
Well, we had to find the Directrix in order to write the equation because we needed the p.
Oh, so then you did like the one you just made that negative
1 over 4 times -2. Well, your p, take the p out because -10 was the p. You're welcome. Alright, what we're going to look at tomorrow. Okay, hope we got you some good notes on all the kinds of stuff that we went over so far. Tomorrow I'm going to give you a practice test. You're going to work on it just like it were the real test. See how you would do on it if it were the real test. Then the next day we'll go over what we need to, and then the next day we'll take it. Look it up. Feel any better yet about it? Putting it all together?
The only one that was hard was the
Second one, it was moved. Yeah, when you scoot it around, it's trickier.